Okay, so welcome to lesson 3.3, solving multi-step equations. So by the end of this lesson, we should be able to solve equations where we have variables on both sides. Okay, oh, I can make this bigger. There we go. Okay, so we're just gonna practice some of the stuff that we know from last time as our warm-up. So let's try this. So remember, we always want to collect our like terms. So in this case, our like terms would just be all the constants. So I'm going to keep my 2x on this side, and then I'm going to move all my constants to the other side. The -5 was already there, so I'm going to start with that. And then for each of the others, I have to, whoops, that's a negative. I have to switch their sign. So +4 becomes a -4, +6 becomes a -6, and -3 becomes +3. So this -2x is here. So we've got what? -5 minus 4 minus 6 is -15, plus 3 is -12. And then divide both sides by -2, x equals 6. Okay, for b, we're going to distribute first. So we've got 5x plus 20 equals 40, and then here we can just simplify our sign. Negative and a negative is a positive. Then again, I want to make sure all my constants are on the same side. So here I'm just going to add them because it's pretty easy. And then this positive 20 becomes a -20. So 45 minus 20 is 25. Divide both sides by 5. And we've got x equals 5. And then last one here, I'm going to leave all my x's together. So this 7x minus 9x, I'm going to leave my 21 minus 5, and then this -6 becomes a +6. So I can simplify here. 7x minus 9x is -2x. And then on this side, simplify. So 21 minus 5 is 16, plus another 6 is 22. And then we're going to divide both sides by -2. And we get x is -11. Now it also wanted us to do a formal check on part C. So formal check, remember that's my left side, right side. So left side was 7x minus 9x minus 6, and my right side was 21 minus 5. So in this case, x is -11. Okay, so we've got -77 plus 99 minus 6, which is 16. And then my right side, 21 minus 5 is 16. So left side equals right side, x equals negative, therefore x equals -11. Okay? Alright, so remember when we have variables on both sides of the equal sign, we have to get all the variables to one side of the equal sign before we can isolate anything. Okay, so we're going to try this next one. So we're going to try each of them, and then we want to do a formal check on A. Alright, so let's give this a try. So again, we want all of our variables on the same side. So this 4y over here, I'm going to make sure it comes over onto the left side. So it's a positive 4y, so it becomes a -4y. And then we can just leave these constants over here. So 2 plus 5 is 7, minus 4 is a 3y, and 14 minus 2 is 12. Divide both by 3, and we get y is 4. And then they want us to do a formal check on this one. So left side is 2y plus 5y, and my right side is 14 minus 2 plus 4y. So let's do my left side first. So 2 times 4 plus 5 times 4. 8 plus 20 is 28. And now we can try the right side. So 14 minus 2 plus 4 times 4. So 14 minus 2 plus 16. 14 minus 2 is 12, plus 16 is 28. So left side equals right side. Therefore, oops, not x, this is y. Y equals 4. Alright, so let's try B here. So we've got a W, a negative 5W, and then this negative 14 is going to become a positive 14W if we collect like terms. Over here we've got a negative 3, and then on this side we have a positive 7, so we want to move it over and make it negative. Okay, so over here we've got W minus 5W is a negative 4W, plus 14 is 10W. And over here we've got negative 10, divide by 10, W is negative 1. Okay, and then this one, so we've got some distributing to do. So we've got X, distribute this negative 1, so plus 3X minus 5, and then we're going to distribute this 7, so 7X minus 7 plus 3. Then let's get all of our variables on the same side. So we've got an x plus a 3x, and then this 7x becomes a negative 7x. And then our constants, well, we already had a negative 7 plus 3 here. And then we're going to move this 5 over and make it positive. Alright, so x plus 3x is 4x, minus 7 is a negative 3x. And then over here we've got what? Negative 7 plus 3 is negative 4, plus 5 is a positive 1. Divide by 3, x is negative 1/3. And yes, we can get fractions as answers. Okay, so moving on. So some success criteria for solving equations. So first we want to distribute into brackets, if possible, right? If we don't have any brackets, then we don't have to worry about it. Next, we want to simplify by collecting like terms. Right, and that would be like on either side of our equal sign, right? So variables to one side and constants to the other. Then we can do that. So collect variables to one side of the equation, and then we can isolate for the variable. Okay, so we're just going to try a couple of real life examples. I think this should be example 3, not 4, but it's alright. And then we'll be done this lesson. So in this case, we've got the Sun Spa charges annual dues of $123. Okay, so this is our Sun Spa, and they're $123 plus $10 per hour. Okay, and then the Moon Spa charges these annual dues of $230 plus $7 an hour. Okay, so we're going to let X represent so what they're asking us for what number of hours would the two spas charge the same total amount? So let X represent the number of hours at the spa. Okay. So we're going to need some equations here. So we need one for the Sun Spa. So they said they charge annual dues of $123 plus $10 per hour, right? Sorry, not equations. We need some expressions. And then the Moon Spa, they said that they charge annual due of $230 plus $7 an hour. Now, our question is actually asking us for what number of hours would the two spas charge the same amount. So when are they equal to each other? So we're going to take our Sun Spa and we're going to set it equal to our Moon Spa. Okay? If they equal each other, that means that they're charging the same amount, right? So then let's get all of our variables to one side. So we've got 10x here, and then this minus 7x, and then we've got 230 minus 123. So we've got 3x and 107 here. divide both sides by 3, x equals, this just gives us a ugly decimal, so we could actually change, one of the only times that changing that to a mixed number would make sense. So this is actually 35 and then 2/3 of an hour. So therefore the 2 spas cost the same amount after 35 and 2/3 hours. Okay. All right. So for this one, we've got a square and an equilateral triangle. Now, in case you don't remember what an equilateral triangle is, that means that all the sides are the same, just like in a square, right? So the square and the triangle have the same perimeter. So what they want to know is what the value of x is. So what they're telling us is that the perimeter for the square equals the perimeter for the triangle. So if we calculated the perimeter for the square, we know all 4 sides are equal. So if one side is 5x plus 3, the total perimeter would be just 4 times that. And then for the triangle, if one side is 7x minus 1, since all sides are equal, we could just multiply that by 3 to get our perimeter. Now if we solve for x, that's what that's what they're actually asking for, right? They want to know what x is, and we know that perimeters are equal. So we can distribute here for each side, and then we can get all of our variables to one side, right? Switch your sign on the one you moved. And then we can simplify here. So what have we got? Negative x and negative 15. Divide by negative 1, right? We can't just leave a negative x, and x is 15. So therefore, the value of x is 15. Okay. All right, and then our last question here. The perimeter of a rectangle is 30 centimeters. If the length is 3 centimeters longer than the width, find the rectangle's dimensions. So we might want to draw ourselves a picture. So the perimeter is 30 centimeters. And then we know that the length is 3 centimeters longer than the width. Okay, so we have width and we have length. And we know that length is like taking the width and adding 3 to it. Okay, so I'm going to say let W represent, whoops, can't spell, represent width, and let L represent length. So I know that for a rectangle, I've got P equals 2L plus 2W. I know that the perimeter is 30. And then in this case, I'm going to let that length, I'm going to use my little equation here. So the length is the width plus 3. And then width is just width. So I'm going to distribute here first. So 2W plus 6 plus another 2W. And then I'm going to move all my variables to one side and constants to the other. Okay. So 30 minus 6 is 24. 2W and 2W, is 4W. Divide by 4, W equals 6. So they want us to find the rectangle's dimensions. So in this case, we need to figure out what length is, because length was W plus 3. So W, we just figured out to be, 6 plus 3. So the length is 9 centimeters, and then the width equals 6 centimeters. So therefore, length is 9 centimeters, and width is 6 centimeters. Okay, and that's the end of this nice short lesson.